All right, guys, welcome back. We're on a new unit today. We're going to talk about linear functions. And overall, in general, I'm going to introduce you to the idea of functions today because some of you guys might be like I was when I was in high school. And I remember high school, even into college, this kind of gray haze void when we talked about functions and linear and exponential and what the point of them is and an equation versus a function. And it was hard for me to learn a lot of the specifics because I didn't really have grounding or understanding of the general concept. So let's dive in, figure out what the heck this stuff is. Okay, what is a function? Well, really simple. The simple, straightforward answer is just a relationship. Between two values. Okay? So, relationship, we're going to translate in math speak into equation. It's a relationship that we can mathematically write out as an equation, and it's always between two values. Let's have an example. I've got the perfect one. Anytime I eat beans, they just kill me. I get killer farts. In fact, it works out generally to the ratio of 1 can of beans ends up giving me at least 5 killer farts. So I end up with 5. Okay? Another way to say this is the beans determine the number of farts I have. Okay? So we see that there is, number one, a relationship between these things, and number two, the beans cause the number of farts, which means the number of cans of beans is really the input, and the output is the number of farts. And so now we have everything we need to write up an equation. We can say, let's move this up. We can say that beans, as our input, we're going to call x. We're going to say our number of farts as the output. We're actually not going to give that a name yet, but it's going to have one momentarily. So if our beans is at the input and it's x, we could really think of an equation that says 5x. 5 is just that multiplier. And we need 5 in this case because we said that every can of beans produces 5 killer farts. So the 1 can of beans multiplied by 5 means I'll now have 5 farts from that can. And x represents the number of cans of beans. That's our beans. That's the input. It's just the number of cans I eat. And that's going to equal the output of our farts. And we're going to say that those are the result or the output. And so however many farts I end up with, it's really a function or a calculation of how many cans I ate of beans in the first place. So it's really a function of the number of cans of beans, which is just to say a function of x. So the output, we could really just say, another way to say it is a function of x as the input. And the way that they denote that in equations is they turn the function into just the letter f, and then to say of x, they put it in parentheses. And so now we've got an equation where my beans are the input and the output is the number of farts, and so that is a function of x. F of x is another way people say it. F of x. And so now we have this idea where it's an equation, but it's got two variables, and so we also call it a function. And it's got one other way it can be written. We can say 5x, and instead of f of x, we can also call it y. And so now we've got really the exact same thing written two ways. We've got 5x as my input. The number of cans of beans is x. So not 5x, excuse me. X is my input, the number of cans of beans I eat. And then the output is f of x, the function, the calculation of what I do to x. And that's my output. And I might call it f of x, or I could call it y. And one of the things to really point out for you guys, these are exactly the same thing. In class, if we're talking about y, it's exactly the same as saying f of x. If we're talking about f of x, it's exactly the same as saying y. We just have two variables that we work with now. We have x, which is the input. We have y, which is the output. And y just has another name called f of x. And this equation in two variables just has a new name. We often call them a function. All right, so let's look at what it does for us if we look at it that way. Input, output, and f of x. We actually just talked about that on the last screen. So let's look at this here. Let's take our fart function. This joke stinks. I couldn't resist. Okay, so we have 5x equals y. Okay? And always when we're graphing right now, the whole idea of a function is because it's in two variables, x and y, we can now graph any function because this is the x-axis going left to right. It's like the original number line you learn when you're a kid. It goes left to right. And then we add the y-axis later going up, down. And so now we have this graphing component that comes in for any function. Because it has two variables, we can graph the x and the y value for the function and make a point. And then we can do multiple different inputs, which is going to give us multiple different outputs, multiple points on the graph. And then we get this shape, this line or this curve, and we can see what this function does with a bunch of different values being used. Okay, and the x value is going to be cans of beans. And this is the case always with your guys' functions. Okay, so down here is always going to be the input, the x-axis. Okay, whatever you're putting in is always going left to right. It's down here. And then the other side is our output, or y-axis, and that's our number of farts in this case. And it always has to be this way because the y-axis always goes up and down, and f of x or y is always the output for the equation. That's just how it goes. So you'll always have x-axis left, right, y-axis going up and down, and that'll be how it connects to your equation. So let's say I have, this is called a T-chart. Let's theorize about me eating cans of beans and see what happens. If I have one can of beans, what's it going to do to me? Well, hopefully you plug in 1 for x, and that's 5 times 1 equals 5. I'm going to end up with 5 farts. And this is a point. We can take that 1 and 5, and we can also write them as a point you can graph. 1, 5. Do you guys remember that? Any point can be written. It's x, then y, alphabetical. And then it becomes a point you can graph. So I'll take that 1, 5, and we'll come over here to our graph, and there's there's 1 on the x-axis, and then 5 on the y-axis is right here. And so the point where they cross, that's 1 comma 5. So if I have 1 can of beans, I'm going to end up with 5 farts. Let's see what happens if the fun continues. With 2 cans of beans, I bet you guys see what's happening here. 5 times 2, I'd end up with 10 farts. I could write that as a point, 2 comma 10. And we can graph that, so we'll give that guy a different color. Let's make that guy blue. So again, 2 now, here's 2 on my number of cans of beans, 10 right here for the number of farts, which means I'm up here. If I had 2 cans of beans, I'm jumping up to 10 farts, and I bet we could speed this up if we did number 3, okay? 3 cans of beans, 15 farts, graph that as a point, so I'm just going to go over to 3, and I'm going to go up to 15, and I'm just going to put a point right there. Now, we can see a pattern developing. I'm hoping you guys see a pattern. And that pattern would be, if I draw a nice straight line, and if I start at 0, and I draw a straight line. Now I'm using the line draw tool, so it's not perfect because I didn't get my dots in a perfectly straight line, but you get the idea. That shows us the relationship of farts and cans of beans. And that's going to continue forever. Just imagine if I ate like 20 cans of beans, what would happen? I think my house would blow up. And this is called, do you guys know what this is called? What type of function this is? I bet somebody did. This is a linear function. Why would we call it a linear function, do you think? Sorry, my screen turned. How about right there? Because the word line is in the word linear. And this type of function makes a straight line when you graph it. That tells us something about the relationship of farts to beans. It's always a straightforward multiple. As we look down the x row, as we keep counting 1, 2, 3, and we look down the y row, we see that that's counting up by a multiple of 5. 5, 10, 15. So that's a linear growth. We continue jumping up by groups of 5, which is pretty obvious when you look at our equation. All we're doing is multiplying any input x by 5, and that gives us our output. So this would just continue for forever. One of the reasons we use linear functions in the real world is to have predictability. So let's say I've never actually tried, let's just be crazy. I've never in one sitting had 10 cans of beans. But if I did decide to eat 10 cans of beans, can we decide how many farts would end up happening? And of course we could. We'd have to go off the chart. We'd have to go off the top of the screen because we know when we plug it in, it would be 50 farts, which would follow our green line way up off the top of the screen. But now we know with predictability exactly what would happen. Now it's obvious on this one because you can see it in your head. It's as simple as 5 times your number. But in the real world, we have equations to model things such as COVID and infection rates and recovery rates. And they will have something that looks like, let's jump to another page. They can literally have an equation that giant supercomputers will create, f of x, so that's like the answer, the outcome, and maybe that's the percent of the population that is vaccinated. Okay, they've got all these ideas about how much vaccine, how effective it is, how much time it will take to disperse it, and then they plug all this stuff into a computer, and you end up with this crazy thing like Okay, and it just goes on and on and on. This equation could be huge. And it's this giant function, and they plug it all into a computer, and they put in all these factors, and then they have no, we have no idea off the top of our head how it's going to work, but they plug it all in, and then they have the function predict. And just like we did on our last page, they're just doing a more advanced version of that. Here for x, that's the input. Maybe that's time, how long it's going to take to get, for what percentage of the population to be vaccinated. And so f of x is our y-axis. And so this is percent of the population that have a vaccination that's actually effective. And they plug in all these factors, and we might see something like this. Over time, it kind of starts slow, but then it starts to gain momentum. And then we see a lot higher percent of the population getting vaccinated, but then it kind of tips off, and it kind of flattens out again. And that might be what the function tells them. And if that did, we would know this is our sweet spot. We got to get into this spot right here. Okay. Once we get to this much time, we're going to have a bunch of the population vaccinated. That's going to be the highest level. But after this time period, all of this, it kind of flattens off, and not much more population gets vaccinated. So this amount of time here really doesn't matter. So we're not going to see much effect anymore after this. And so all of that math tells us, right here's our sweet spot. We need to have this much time for it to work so that we can get that much of our population vaccinated. And all that is possible because of this function that they are using, and they're plugging it in to predict future values and find what their outcome is, what the output is from all that information. Okay, let's get you to your homework. All right, here's 2 of the 3 homework problems. Let's look at them real quick. Number 1, write the function. So for every minute I ride my kid's hoverboard, I end up with 6 more bruises. Can you write that out as a function, just like we did with cans of beans and farts? And can you write it out using both the f of x and the y notations? So it'd be the same function, same equation, but you can write it out with a y, or you can write it out using an f of x. Do it both ways. All right, number 2. Given the function f of x equals negative 3x, can you explain what that's saying? If x is the hours of exercise and f of x is my weight, what is that equation saying? What is that function telling me? All right, pause it here. You can do these, and then I'm going to flip to the other page in just a sec to explain the third problem. You can see that. All right, here's problem 3. Given f of x equals negative 4x, fill in a t-chart. We just did the t-chart on the other examples over there on the left with 3 sets of values. Okay, those 3 sets of values, those will make points for you. Then graph the function using those 3 points. And don't forget, you have to label your x and y axis. They don't mean anything until you've got some values labeled. And you probably want to wait to create your 3 t-chart points, your sets of x, y, before you label it. Because depending on the kind of function, you might need to go into the negatives, you might need to scale really high into the positives, or you might just need 1 through 10. But it really depends on what you're graphing to determine that scale. So you should calculate your points first and then scale accordingly. All right, good luck guys, peace out.